Welcome to our very first video describing the concept of scale. Scale is important because it's related to how we count. And I'm going to take you through a set of counting exercises. Why are these important? Well, counting is important because we need to know how to measure events. We need to know, for example, how to say whether the following statement is true or false. The Fukushima disaster was 168 times greater than the bomb dropped on Hiroshima. So let's start. Supposing we only have 2 fingers. So we can only count on 2 fingers. So let's start counting. 1 finger. Here is 1. Normally we call that the units. Now we got to use up the 2nd finger. Here we have what we call 2. Notice that the 2 green cylinders are in a line. Well, we doubled the unit to get 2, so what's the next step? We're going to double the 2 that are arranged in a line to get a square. And how many cylinders are there in the square? There are 4. 2 times 2. Note that to position yourself in a square, you need to have 2 dimensions. What's the next step? We went from 1. We doubled it to 2. We doubled it to 4. The next step, yes, you got it correctly. It is 8. We now have a cube of these green cylinders. There are 2 by 2 by 2 cylinders. 2 times 2 times 2 again gives us 8. We are counting base 2, and that's the base that's usually given the letter B. Base 2 is used for all kinds of counting when you're dealing with computers. One final thing to note. How many dimensions does this arrangement use? Well, it's a cube. So to be in a cube, you need 3 dimensions. How about a plane? This is a plane. The arrangement is planar. How many numbers describe a position in a plane? 2. And how about a line? The arrangement is linear. 2 cylinders, 1 dimension. And how about this guy? A point. How many dimensions does a point have? Let's start it all over again with a 3-fingered base. Now we have 3 fingers for the base. The unit is still 1. We're going to use up all 3 fingers, so we are going to have 3 in a line. What do we do next? Repeat that 3 times. 3 times 3 is 9. You can see the arrangement goes from linear to planar. And what's the next step? Replicate by 3 again. 3 layers of 9, 27. Here you see the cube even much more well defined. 3 dimensions to build this arrangement. 2 dimensions to build this arrangement. I say arrangement because it is the way we arrange the cylinders. A linear arrangement. Dimensions 3, 2, 1. What's the dimension of a point? You can start to see how the scale is growing. Let's try 10. Now we're to 10 fingers. Replicate the unit 10 times. We get 10 in a line. Now we replicate that line to get the progression of a plane. Here it is. How many are here now? 10 times 10. 10, 20, 30, 40, all the way up to 100. What would we do next? Well, we would do the cube. I have a sad story to report. The Lego store ran out of 1,000 green cylinders, so we don't have the dimension and scale for you. However, this whole exercise was constructed 50 years before Lego was invented by a person called Maria Montessori. And here I have the complete set, counting by tens, to show you the scale. She used beads. So, the unit, 1. Replicate the unit 10 times. Linear dimension. The arrangement is in a line. There are 10 beads. Replicate the 10 beads 10 times horizontally to get how many beads? Well, we all know that 10 times 10 is 100 beads. And now, the real pièce de résistance, replicate that planar pattern of 100 beads 10 times to get 1,000 beads. We now see the idea of scale represented geometrically. The base is 10 in this picture. This requires 3 dimensions to locate a bead. The dimension associated with this is 3. For those of you who are aware of powers, which will be summarized later, 10 to the power 3, the dimension. 100, 10 squared, 10 to the power 2 is 100. And the linear case, simply 10. 10 to the power 1 is 10. And this little guy, 10 to what power and what is it equal to? Well, we know what it's equal to. It's equal to 1. 1, 10, 100, 1,000. What is the power of 10 that gives us 1? Well, you can kind of figure it out. We go from 3, we subtract 1 to get 2. We subtract another 1 to get 1. We subtract another 1. 1 minus 1 is 0. 10 to the 0 is equal to 1. This will be summarized in the following video on a PowerPoint summary.